Hello class. In this lecture, I will be discussing to you some of the fundamental topics in the subject trigonometry. Trigonometry is defined as a branch of mathematics dealing with the relationship of the sides and angles of triangles and with the relevant functions of any angles. Since we are dealing here with angles, what are the units that are commonly used in angles? We have degrees, radians, grads, and mils. But commonly, radians at degrees ang laging ginagamit. And usually, mas recommended ang degrees. But to some applications such as sa calculus or any other subject, it is more convenient that radians will be used as a unit of angle. But commonly, for all or majority of our subjects that are dealing with angles, we commonly use degrees. So, let's take a look at the unit conversion factors that we can use in converting some angles. So, for 1 revolution of angle, so if this is the Cartesian plane, ang angle sinusukat siya depende dun sa reference direction mo papunta dun sa another direction. But if we have a reference direction of 0 here at the positive x direction in the Cartesian plane, at ito yung negative x, ito naman yung positive y, negative y direction. So if we have 1 revolution of angle from the origin, like that, counterclockwise, in degrees, ang equivalent niyan ay 360. For radians, the equivalent is 2 pi. For gradians, 400. So, isang revolution, 400. And for mils, 6,400. So let's try to apply these conversion factors so that we could easily convert some of the units of angles to another system of units. So, example, express 45 degrees in radians, grads, and mils. So given yung degrees natin na 45 degrees, naka-degrees na unit, kukonvert natin siya sa radian muna. So, for radian unit, as we recall, for a 1 revolution, we have 360 degrees. And for radians, we have 2 pi. Now, if I'm going to convert degrees into radians na unit, I must convert it first to revolution, then from revolution going to radians. So, just multiply here 45 degrees, yung equivalent conversion factor natin for 1 revolution. So, in order for us to cancel the degree, dapat dun sa denominator natin yung degree na 360 degrees and 1 revolution. Then, if cancel na yung unit natin na degree, matitira yung unit na revolution, but that's not the required unit. Therefore, I must apply another conversion factor na 1 revolution is equivalent to 2 pi radians. Now, the revolution unit is cancelled. So, some of you might just simply simplify this this conversion factor by multiplying 1 over 360 to 2 pi radians. So, let's see if what would be the equivalent conversion factor of these two. So if I multiply these values, ang kalalabasan ay 2 pi radians over 360 degrees. So, cancel out yung 2, we have pi radians over 180 degrees. So if we want to directly convert degrees into radians, we can simply just multiply pi over 180 degrees. Then yun na yung ating value for the radian. Now, going back to the problem, if I'm going to multiply 45 by pi over 180, okay, radians, we will have an answer of 45 times pi over, pi over 180. That is pi over 4. Okay, so that's the answer, pi over 4 radians. How about when we convert 45 degrees into grads or gradients? So let's solve. For 45 degrees, just apply again the equivalent conversion factor for 360 degrees, 1 revolution, then for 1 revolution equivalent to 400 grads. So if we want to directly convert degrees to gradients, we simplify this to conversion factors by multiplying it, which is 400, okay, 400 over 360, right? 400 over 360. 400 over 360, simplify, we have, okay, grads 10 over 9 grads per degrees, which means that for every 10 gradients we have equivalent of 9 degrees. So if I'm going to directly compute using the conversion factor, simplified conversion factor, which is 2 gradients over 9 degrees, we will have an answer of 45 10 over 9. Okay, 50 gradients. Okay, 50 gradients. Next, convert to mils. 45 degrees, 360 degrees per 1 revolution, and 1 revolution is equivalent to 6,400 mils. Again, simplify the conversion factor so that we can directly convert degrees into mils. 6,400 mils over 360 degrees. Simplify, it is equivalent to 160 over 9. 160 over 9 if we divide both the numerator and denominator by 40. So, for every 160 mils, it is equivalent to 9 degrees. So, 45 times 160 over 9. This is over 9. Equals to, okay, times 45. 800 mils. And that's the answer. Okay? So what are the types of angles? We have an acute angle, an angle between 0 to 90 degrees. Right angle, if that angle is exactly 90 degrees. Obtuse angle, angles between 90 to 180 degrees. And a straight angle is an exactly 180 degrees in value. So, how about angle pairs? Special names are given to pairs of angles. which their sum might be equal to 190 or 180 degrees. What are these? For a pair of angle that has a total of 90 degrees, they are called complementary angles. While a sum of 180 degrees of two angles, they are supplementary angles. So which means if we have two angles that are adjacent to each other, and when you add the two angles, let's say this one, angle A, angle B, then when you try to add their values and they are equivalent to 90 degrees, which means that they are complementary angles. Angle A is complementary to angle B. The same way for supplementary angles, having two adjacent angles that has a sum of 180 degrees. So they are supplementary. So what are the 6 trigonometric functions that are used in engineering or in trigonometry? These are the trigonometric functions that we use. We have sine, cosine, tangent, cosecant, secant, and cotangent. So usually, one of their application of this this trigonometric function can be derived from the right triangle. So if we are going to solve a right triangle, there are solutions using trigonometric function given the sides of a right triangle and an included angle. So for the sine function, it is equivalent to the opposite side. So the sine of that angle, of this angle, is equivalent to the opposite side A over the hypotenuse. So kung meron tayong right triangle dito, by the way, a right triangle is a triangle having an angle of 90 degrees. So isa lang ang interior angle nung triangle na merong 90 degrees. It can be called as a right triangle. Then the angle or the side opposite to that right angle, that's what we call the hypotenuse. And it is the longest side of a right triangle. Now, solving using the sine function, okay, sine function is equals to the opposite side, which is this side A, over the hypotenuse, side C. For cosine function, given ang angle theta, it is equals to the adjacent side or yung katabing side, which is side B, divided by the hypotenuse, C. Tangent, okay, tangent is equals to the opposite side, A, divided by the adjacent side, B. When it comes to the cosecant, secant, cotangent, they are just the reciprocal value for the sine, cosine, and tangent. As you can see here, for the cosecant, it is equals to 1 over sine theta. Kaya kung makikita nyo dito sa solution, it is just equals to the hypotenuse over the opposite side, C over A. So, reciprocal lang ng value. Same for secant, 1 over cosine, and cotangent is 1 over tangent theta. So, that's it. Let's try to solve this right triangle by using those fundamental trigonometric function. Find the length of side BC or this distance X and find the side AC or the side Y or the distance of Y. Given angle is 50 degrees and a hypotenuse of 25. So how do we solve that? So it is important that we have our scientific calculators in solving this problem, so that we will not have a hard time in solving trigonometric functions. So let's find first side BC. Okay, for side BC, given an included angle, what will be the most convenient trigonometric function that we will use in order to solve the value for side BC, or the side X? So what trigonometric function? The trigonometric function that we can use is sine. Sine theta is equals to what? Opposite over the hypotenuse. So side BC divided by the hypotenuse, which is 25. Theta is given, therefore sine of 50 degrees is equals to BC over 25. Then determine BC by multiplying both sides by 25 to eliminate the denominator 25 on the right hand side of the equation. So 25 sine 50 degrees, that's the solution for side BC. So compute 25 sine 50. So make sure that your calculators are in a degree unit. Where can you see that? Right here, as you see here, this letter D here means that the unit for angles that you are using is in degrees. If the given angle is in radians, we can simply set up our calculators by changing this into radians mode. So if we're going to change the unit to radians, just click here, mode, and shift mode, and click number 4 for the radian degree. Okay, for radian unit, So in your calculator, it is now changed to radians. But again, careful in using or changing units in calculator, especially when you are solving some problems that involve trigonometric function. Because if we try to solve this problem that has a unit of degrees for angle, and your calculator is in the radian mode, it will give you the wrong answer. When we solve that, it is negative 6.5597, but that's not the answer because we are in radian mode. So if I'm going to change again the unit for angles, shift mode again, and click that radian or yung number 3. So letter D na ulit. So solve in degree mode. That's the answer, 19.1511. So always check your calculator if it is in degree or in radian mode while solving. 19.1511, 1511, unitless. That's it. How do we solve find AC? For side AC, we can use the cosine function. Cosine theta is equals to what? Adjacent side divided by the hypotenuse. So if I'm going to substitute the given, cosine 50 degrees is equals to the adjacent side, which is yung y, or let's say AC, side AC, to be divided by the hypotenuse 25. Therefore, multiply both sides by 25. Cosine 50 degrees is equals to AC. Compute. Just change the trigonometric function to cosine. 16.0697. 16.0697 if we use four decimal places. That's it. So careful in typing in our calculator, especially in writing the product of a number and a trigonometric function. You might write it as cosine 50 to be multiplied by 25, but when you try to type that in calcu, medyo ingat lang tayo. Kaya mas maganda na yung number mismo ang iuna mo dun sa trigonometric function, because you might type in your calculator 50 times 25 kung dinire-diretso mo lang, or yun nga. So magbibigay sila ng maling sagot kasi the solution shows you that you must evaluate first the trigonometric function, yung sine or cosine, then you multiply it to 25. Okay? So, next. Now, another application for trigonometric function is we can use it in solving some problems that involves angle of elevation and angle of depression. The angle of elevation is the angle formed by a horizontal line and the line of sight up to an object when the object is located above the horizontal line. Let's say we have here an instrument and there is an object there. Then here is your line of sight. So the angle of elevation is measured from the horizontal line from that instrument going to the line of sight up going to the object. So this is the angle for the angle of elevation. This is essential, especially if we want to determine the height or the difference in elevation between two objects, as well as determining the distances between the two objects, horizontal distances between the objects, using trigonometric functions. Same way for angle of depression, it is measured from the horizontal line of sight going to the line of sight down to the object. Okay, beneath the horizontal line. Say this is your instrument here, the object is below. If this is the horizontal line of sight, then you take the reading here, that's the line of sight, then measure the angle, then that's the angle of depression. Now let's try to solve some problems that involves angle of depression. Sample. An observer standing at the top of a vertical cliff spots a house in the adjacent valley at an angle of depression of 15 degrees. The cliff is 50 meters tall. How far is the house from the base of the cliff? First, draw the figure. We have an observer at the top of vertical cliff. So this is the vertical cliff. Then this is the location of the observer, let's say point A. Then the house is below the horizontal line of sight, and we have an angle of depression of 15 degrees. The value for 15 degrees is measured from the horizontal line of sight of the observer. Okay, so if this is the horizontal line of sight of the observer, we have 15 degrees here going downward, and let's say this is the location of the house, point B. So this is the angle 15 degrees. The cliff is 50 meters tall, and we are required to determine the horizontal distance, or how far is the house from the base of the cliff. This is the base of the cliff right here. Then determine the horizontal distance going to point B. So say distance x. Now, since this is a right triangle where we can form a right angle here, and we have a triangle, so this is a right triangle, but we have only one given angle, which is the right angle. We need another angle so that we can solve the horizontal distance x. So given the angle of depression of 15 degrees, how can we use this angle of depression in order for us to determine the other angle of this right triangle form? So as you can see, they are complementary angle. This interior angle of this triangle and the angle of depression 15 degrees, they are adjacent, and since we have a vertical cliff and a horizontal line of sight as a reference direction for the angle of depression, we can form a right angle. So if these angles are complementary angle, if I'm going to determine the value of this interior angle, I'm just going to subtract 90 degrees by 15. So 90 minus 15 degrees is equals to 75 degrees. So that's the interior angle. Now, if we are going to rewrite or redraw the figure, we have a right triangle here with an interior angle of 75 degrees at point A and 50 meters distance on this side here. Let's say this is point C, the base of the cliff. And what trigonometric function that we are going to use so that we could compute x? What trigonometric function that we can use? It is tangent. Why? Tangent of an angle is equals to the opposite side of the angle and to be divided by the adjacent. So substitute tan 75 degrees is equals to opposite is x divided by adjacent side is 50 meters. Then multiply both sides by 50 here. We will have cancel. Okay, I'll continue my solution here. 50 meters tangent 75 degrees is equals to x. Compute 50 tangent 75. Enter. 186.6025. Sorry, 186.025 meters. So that's the answer. Okay, now here are the fundamental identities. You have the cosecant, secant, tangent, and cotangent. For cosecant, the reciprocal of sine, and secant, cosine, and for the tangent, it is also equivalent to the ratio of sine theta over cosine theta. For cotangent, equals to cosine theta over sine theta, or reciprocal of 1 of tangent theta. Pythagorean identities, it is derived from Pythagorean theorem. So given a triangle that has sides of A, B, C, and an included angle of theta. So if we determine the if we use the solution for Pythagorean theorem, we have a squared plus b squared equals to c squared. Divide both sides by c squared. We will have a over c raised to 2 plus the quantity of b over c raised to 2. So since a over c is equivalent to sine theta, where sine theta is opposite over hypotenuse, so substitute a over c by sine theta. For b over c, the adjacent to that angle divided by the hypotenuse equals to cosine theta, substitute. So we will have an identity of sine squared theta plus cosine squared theta is equals to 1. So sa pagre-raise ng isang trigonometric function, if a trigonometric function is raised to a certain power, so yung nare-raise dyan ay yung trigonometric function, hindi yung angle. Okay? So if you apply the power, the trigonometric function is the one that is raised when you write it down. So another Pythagorean identity, if we try solving it again by dividing both sides by b, okay, by b squared, the Pythagorean theorem, we will have a over b squared plus 1 equals to c over b squared, where a over b is equivalent to the value for tangent theta and c over b is equivalent to secant. Therefore, we can rewrite our solution by simply writing tangent squared theta plus 1 equals to secant squared theta. So that's another Pythagorean identity. Another, if we divide both sides by a squared, we will have 1 plus cotangent squared theta equals to cosecant squared theta. Now, why is it important to be familiar with these identities? These trigonometric identities will be useful in simplifying long equations that have trigonometric functions. So some problems that has trigonometric functions are difficult to solve, especially in determining some variables. It is harder to be solved if we simply use the stated trigonometric function there. So we can try substituting some trigonometric function using these identities in order to shorten that equation. Later on, we will answer and simplify some trigonometric functions using these identities. For trigonometric functions that has sum and difference of its angles, it can be written into a new form. For cosine alpha plus beta, it is equals to cosine alpha cosine beta minus sine alpha sine beta. For sine alpha plus beta, it is equals to sine alpha cosine beta plus cosine alpha sine beta. Tangent sum of alpha and beta, it is equals to tangent alpha plus tangent beta divided by 1 minus tangent alpha tangent beta. Sine alpha minus beta, sine alpha cosine beta minus cosine alpha sine beta. Cosine alpha minus beta, cosine alpha cosine beta plus sine alpha sine beta. Tangent alpha minus beta, tangent alpha minus tangent beta plus divided by 1 plus tangent alpha tangent beta. For double angle formulas, these are the double angle formulas that we can use. This one for sine 2 theta, that's the equivalence 2 sine theta cosine theta. For cosine theta, cosine squared theta minus sine squared theta. Okay, it is also equivalent to 2 cosine squared theta minus 1. It is also equal to 1 minus 2 sine squared theta. Okay, for tangent 2 theta, 2 tangent theta divided by 1 minus tangent squared theta. Half angle formulas. So these are the half angle formulas. Okay, so we can use that in some problems. Product of functions. For product of cosine of different angles, we can rewrite that into this form. For product of two sine functions, this one, sine and cosine and sine. So these are included in your worksheet, in your module. So just review these functions. Product of functions, half angles, double angles, equivalents. Example, find the value of sine theta plus cosine theta tangent theta to be divided by cosine theta. So, let's simplify this expression. First, distribute the denominator cosine theta. So, I write here sine theta divided by cosine theta plus cosine theta tangent theta divided by cosine theta. So you know, sine theta over cosine theta from the fundamental identities, it is equivalent to what? Okay, sine theta over cosine theta is equals to tangent theta. So we can rewrite that into tangent theta plus, in this term we can cancel out cosine theta. So we have tangent theta. Now by adding trigonometric function, don't add the angles, but the trigonometric function serve as like a variable that it is a single value. Okay, so if I add tangent theta plus tangent theta, it should be considered like term if they have the same value for the angle. But if they have different value for angle, you can add that, especially if the angle is variable. So add the two tangent theta to tangent theta. Okay, that's 2 tangent theta. So that's the simplest form of this expression. Okay, next, find the value of y in the given y equals to 1 plus cosine 2 theta to be multiplied by tangent theta. So we have a double angle here, cosine 2 theta. So if I'm going to rewrite it, 1 plus cosine 2 theta tangent theta. Recall the equivalent value for cosine 2 theta. For cosine 2 theta, it is equals to cosine theta or cosine squared theta minus sine theta times sine theta or sine squared theta. Now, if I'm going to substitute that here from the original equation, we will have 1 plus cosine squared theta minus sine squared theta. Now, how about tangent? What is the equivalent value for tangent? It is sine theta over cosine theta. So our equation becomes longer. So let's try to find some identities within this equation. So as you can see here, we have 1 plus cosine squared theta minus sine squared theta. So we cannot cancel out cosine or sine here because they are this is an expression with different they have different terms. So let's take a look at 1 and minus sine squared theta, or cosine squared theta, sine squared theta, and 1. Do you see any relationship between the three, or do you recall some any identity from this Pythagorean identity from this expression? So as you recall on the previous slides, we have sine squared theta plus cosine squared theta equals to 1. So from that, if I want to determine the cosine squared theta, it is equals to 1 minus sine squared theta. So therefore, cosine squared theta is equals to 1 minus sine squared theta. So if I will rewrite the equation, diba? Parehas lang siya. Yung 1 minus sine squared theta plus cosine squared theta. So this is just the same here. Ni-rearrange ko lang. Okay? This term here, 1 minus sine squared theta, is equivalent to cosine squared theta. Therefore, it is cosine squared theta plus cosine squared theta times sine theta over cosine theta. So, we eliminated 1 minus, we simplified 1 minus sine squared theta into cosine squared theta. We can now combine like terms. So, cosine squared theta, pwedeng i-add. Magiging 2 cosine squared theta. Therefore, we can multiply it to sine theta, cosine theta. So, this is cosine squared theta, this is cosine theta. Cancel out cosine sa denominator. Cosine theta na lang titira. Therefore, y is equals to 2 cosine theta sine theta. And that's the answer. Next. Sorry. But before we proceed to the next problem, 2 cosine theta sine theta, is there an equivalent trigonometric value, identity for this value, 2 cosine theta sine theta? For a double angle for sine, di ba? Kung i-recall natin yun, di ba, equivalent niya ay sine theta cosine theta plus cosine theta sine theta, or they are like terms, sine 2 sine theta cosine theta. So therefore, this is just equivalent to 2 sine 2 theta. So this is the final answer. This is the simplest form of this equation. Okay, y equals to sine 2 theta. So it's easier to evaluate the value for theta or for y if the angle is given. Next, simplify the equation sine squared theta times 1 plus cotangent squared theta. So as you can recall, cotangent is equivalent to cosine theta over sine theta. So if we have sine squared theta times 1 plus cotangent squared theta, when we determine the square of this is also equivalent to cosine squared theta over sine squared theta. So, common denominator is sine squared theta. Evaluate 1 plus cosine squared theta over sine squared theta. We have sine squared theta as common denominator. Divide this times 1 sine squared theta. Divide this 1 times cosine squared theta plus cosine squared theta. Now, cancel. What remains is sine squared theta plus cosine squared theta. Okay. From the Pythagorean identities, we have sine squared theta plus cosine squared theta is equals to 1. Therefore, the answer is 1. So it is really important to be familiar with the trigonometric identities because it really helps in simplifying some trigonometric equations. In the last part of your module, you can see there some practice problems for you to practice solving trigonometric equations that involves using trigonometric identities. So in sine law, this is essential for determining some unknown sides and unknown angles in a triangle. So the solution for sine law is just simply the ratio of a side over the sine of its opposite angle. It is just equals to the other side to be divided by the opposite or the sine of the opposite angle. So let's use that in this example. In a triangle ABC, where A is 45 degrees, C is 70 degrees, side opposite angle C is 40 meters long. What is the side opposite angle A, or yung length of side opposite to angle A? So draw first the triangle so that we can visualize the given angles and sides. So for angle A, 45 degrees, angle C is 70, and opposite angle, the opposite side to angle C is 40 meters long. So this is side C, 40 meters. What is the side opposite angle A? This one. What is the length of side A? So the solution is using by sine law. But first, let's verify if really sine law can solve this. We have A over sine angle A equals to B over sine angle B equals to C over sine angle C. So based on the given, we have angle A, yes, side C, this one, given. Angle C is given, so we can equate this one. Since unknown is side A, we can equate this one and for side C and angle C. So equating the two, we have A over sine A equals to C over sine angle C. Substitute. Okay, just rewrite the given. Given is angle A is 45 degrees, angle C is 70 degrees, side C is 40 meters. Substitute. Before we substitute, transpose sine A to the right hand side of the equation, or simply multiply both sides by sine A. We will have C sine angle A over sine angle C. Substitute the given. C is 40 meters, sine 45 degrees to be divided by sine 70 degrees. Compute using our calculators. 40 sine 45 divided by sine 70 equals to sine 70, 30.0995 meters. So that's the answer. That's the solution using sine law. How about cosine law? So here are the formula for cosine law. Given the three sides and an angle A squared equals to B squared plus C squared minus 2BC cosine A. Given three sides and angle B, three sides again and angle C. So as you can see here, we have a pattern that if on the left hand side of the equation is the side, okay, the angle to be applied by the cosine function is the angle opposite to that side. Same here for B, angle B, C, angle C. So let's solve using cosine law. In a triangle, find the side C. If C is equals to angle C is 100 degrees, B is, or side B is 20, and side A is 15. So let's draw the triangle. Since we have used letters A, capital letter A, B, and C for the angles, and for the sides, small letter A, B, and C. For angle C, this is 100 degrees. Okay. For B, 20. unitless. A is 15. Okay, using cosine law, you have to identify first the given and the unknown, so that from the three solution using cosine law, you have to identify what solution here is the most convenient, so that you cannot you can simply substitute all the given and determine the one unknown. So based on the given, we can use the third solution, which is c squared is equals to a squared plus b squared minus 2ab cosine angle c. Rewrite the solution here: c squared equals to a squared plus b squared minus 2ab cosine angle c. So that's it. Since side c is unknown, okay, equate square root both sides, isolate c, so square root both sides by, and the second degree, or the exponent of c will be cancelled out. So a squared plus b squared minus 2ab cosine c. Rewrite the solution: square root of a is 15 square plus 20 square minus 2 times 15 times 20 cosine angle c 100 degrees. So we can directly solve that in our calculator. Solve square root 15 square plus 20 square minus 2 times 15 times 20 cosine 100. Okay, is equals to 27.0035. And that's the answer. Okay, so that ends our lecture for plane trigonometry. If you are searching for some topics about triangles, that will be discussed on our topic about plane geometry. So we just focused here on the topics about the identities and some applications of trigonometric functions. So thank you for watching, and God bless.